Gravity is everywhere. No matter where you go, you can't seem to escape its force. The Force. I wonder if Obi-Wan Kenobi was talking about gravity when he was talking with Luke Skywalker about the Force.
Vader was seduced by the dark side of the Force.
The Force?
And the Force is what gives the Jedi his power. It's an energy field created by all living things. It surrounds us and penetrates us. It binds the galaxy together.
Every time you jump, you experience gravity. It pulls you back down to the ground. Without gravity, you'd float off into the atmosphere, along with all of the other matter on Earth. You see gravity at work any time you drop a book, step on a scale, or toss a ball up into the air. It's such a constant presence in our lives, we seldom marvel at the mystery of it. But even with several well-received theories out there attempting to explain why a book falls to the ground, they are still just theories. The mystery of gravity's pull is still intact. So what is gravity? In the movie Back to the Future Part 1, there was a character called scientist Dr. Emmett Brown. In the 50s, he began to hypothesize that gravity was changing in the year of 1985.
Precisely.
Whoa, this is heavy.
There's that word again, heavy. Why are things so heavy in the future? Is there a problem with the Earth's gravitational pull?
What?
Gravity does not change with time. Many researchers have looked for a possible variation in the strength of gravity without success. Some feel that stronger gravity in the distant past might possibly have helped trigger star formation or the Big Bang itself. Even with a long time scale, however, gravity appears to be perfectly constant. Gravity, therefore, does not solve the problems of Big Bang cosmology. A balloon, as you know, is filled with almost the same air as the air surrounding it, which all has mass. The balloon itself also has a mass and is much more dense than the air in and outside the balloon. Gravity pulls the air equally so it stays in place. When the air is inside a balloon, gravity pulls the balloon down while the air wants to stay due to inertia. So because of that, the balloon has to drag the air down along with itself. So what do we know about gravity? We know that it causes any two objects in the universe to be drawn to one another. We know that gravity assisted forming the universe, that it keeps the moon in orbit around the Earth, and that it can be harnessed for more mundane applications like gravity-powered motors or gravity-powered lamps. Sir Isaac Newton defined gravity as a force, one that attracts all objects to all other objects. We know that Albert Einstein said gravity is a result of the curvature of space-time. These two theories are the most common and widely held explanations of gravity. Although many people had already noted that gravity exists, Newton was the first to develop a cohesive explanation for gravity. Albert Einstein, who won the Nobel Prize in Physics in 1921, contributed an alternate theory of gravity in the early 1900s. It was part of his famous general theory of relativity, and it offered a very different explanation from Newton's law of universal gravitation. Einstein didn't believe gravity was a force at all. He said it was a distortion in the shape of space-time, otherwise known as the fourth dimension. Gravity affects many things. Consider the chart. Let's start with gravity. Gravity is one of the four fundamental forces, which exerts a force described by the law of gravity, called the weight, which is equal to the mass times the acceleration of gravity. Gravity provides the necessary centripetal force to produce orbits, including circular orbits, also binary orbits, and orbital speed. Gravity decreases by inverse square law, producing the tides, mainly by the moon, but including a sun tidal effect, and other small effects such as Jupiter effect. Gravity has an associated potential energy which determines escape velocity. Gravity governs trajectories. Gravity is never pushy. Gravity allows pulls it never pushes. For instance, Earth pulls on the moon, but the moon also pulls on the Earth. Sublunar is the moon's orbit and is subject to its influence. Antipodal is the opposite side of the Earth in this case, in relation to the sublunar area. While Earth keeps the moon in orbit, the moon does its own pulling. You can see the effect of the moon on the Earth in the ocean tides. On every coastline of the planet, you can watch the level of water rise and fall. This is due to the moon's pull on Earth. The game of tug-of-war is an example of two forces pulling on each other. This is just like the relationship between Earth and the moon, the sun and the planets, and anything else with mass. Sir Isaac Newton lived from 1643 to 1727. Newton watched around him and began to see patterns in nature. One pattern became his theory of gravity. Newton noticed that gravity is all around us, between any two objects, no matter their size. For instance, Earth is very large compared to a ball. Keep in mind that a ball and a rock both have mass and create their own gravity, but Earth is much bigger. This means that any object that falls on Earth, no matter its size, will fall at the same speed. Drop a ball and a rock off a bridge at the same time, and both will accelerate at the same rate. The only thing that would slow them down is air resistance. You can feel air resistance if you open a window in a car and stick your hand out. The speed of the car will determine the strength of the air resisting your hand. Gravity is all around us. It keeps us safely on Earth's surface instead of floating out into airless space. Gravity keeps the moon around the Earth and keeps Earth moving around the sun. Life on Earth would not be the same without it. Gravity is here to stay. This is a good thing since we don't want to drift away.